Hello guys, so in this video we'll be discussing maximum contiguous subarray or Kadane's algorithm. So first of all, let me explain the problem to you and then we'll discuss the solution. So we are given an array and we have to find the maximum sub of any subarray of this array, right? Such that we have to pick a subarray such that its sum is maximum, right? So, and a subarray is always a contiguous section of an array. So this entire thing can also be called a subarray. If I start from here, and I end here, this is also a subarray. This section is also a subarray. Similarly, I can start at 3 and end at some place, so this would be a subarray, right? So the sum of this subarray, for example, would be how much? It would be 1, 0 and minus 2. Similarly, sum of this subarray would be 6, right? So we have to output the maximum sum of this subarray. And if you go by a brute force, what you can think about is that this is going to take O of n cube time. How? Like we might pick two. We might have a for loop for picking the first element, and after picking the first element, we can select which element to end at. Like we could end at 3, or we could end at 4, so this would be our window, or we could end at 1, so this would be our window, and whatever the sum is inside it will calculate it. So first we'll have to pick the starting point, and then there will be a loop which will pick different ending point, and for each ending point then we'll see that how to calculate the sum in between. Then we'll have to again run a for loop inside, so again a for loop to calculate the sum, so it will be O of n cube. So this is brute force. Obviously we can do a little better and reduce it to O of n square by picking the first element and then picking the second element. So I pick the first element and I pick the last element. Now for the sum, rather than starting from beginning and adding these two, we can have some sort of a variable which stores the previous sum, right? And then when we increase our window from here to here, we just need to add minus 2 to it. Okay, and when we increase our window, we just need to check whether this window has the sum maximum than the previous window. If it is, then we can store the answer. So this is how it can be done in O of n square. Okay, so before we start, since the name is Kadane's algorithm, I think that we should look for its history. So let me give you a glance at its history, how it came about. So a brief history. So Grenander was solving some problem which was related to image processing or something. So he needed to solve this problem for maximum subarray, maximum sum of contiguous subarray. Now he knew that it was coming in O of n cube, but he then reduced it to O of n square with his algorithm, which we discussed earlier, right? Then there was a guy, Michael Shamos. So he got to know about this problem and he further reduced the time complexity from O of n square to n log of n. So in Wikipedia it's given that he took a day to do it. And then what happened is that when he was giving a seminar in Carnegie Mellon University, there was a guy named J. Kadane. So J. Kadane, he immediately thought of the approach and reduced from n log n to n linear time approach. So this algorithm came to be known as Kadane's algorithm. So we'll be discussing how he came about this algorithm. I mean, what the Kadane's algorithm is. So obviously it's a linear time algorithm. So let's try to understand what it is. So let's say we are given an array, and this is the array that we are given, and we need to find the maximum sum contiguous array. Okay, so let me start over here. So what happens is, the first number that we see, I am going to ask this question again and again, that what is the maximum sum that we can get ending at this index. Okay, so what is the maximum sum that I can get ending at this index? It's going to be minus 2, because I have to pick at least one. So minus 2 is the only possibility, the subarray, right? Then I can ask myself, what is the maximum sum that I'll get if I end at minus 3? So now if I end at minus 3, I have two options with me. Either to continue with my previous subarray, in that case I'll have to add minus 3 to it, or I can start afresh minus 3. and these two decisions will be taken on the basis of the fact that which is better. So -2 and -3 will give me -5, and -3 itself is -3. So rather than continuing with this subarray and adding -3 to it, I can start afresh. That would be a better idea. So I'll start afresh and I'll write -3. I'll not extend the array. Then I come at 4, and then I see that again, should I start again, or should I continue with my previous array? So my previous array was -3, previous sum was -3, and if I add 4 to it, I get 1. And if I don't continue with my previous sum and I just start afresh, then I have 4. So which is the better idea? Yes, to start afresh. So I start afresh and I get 4. Similarly, I come at -1 and I have two choices. Should I start afresh or should I continue with the array I have? So I will continue. Why? Because -4 plus 4 and -1 will give me 3, and -1 will give me -1. So 3 is a better option, right? So rather, let's continue it. So we'll extend it. Again, I have a choice. Should I start afresh with -2, or should I continue my previous array? So if I add 3 and -2, I get 1, and if I just have -2, it's -2. So 1 is better option. So I'll extend this array. Then I come at 1. So starting afresh or continuing. So 1 plus 1, continuing would be a better idea. Again 5 I have, so continuing would be a better idea. 7 I get, and now I have two options. Should I start afresh? Should I keep it -3, or should I continue? So 7 minus 3 is 4. So 4 is better than -3. So this is it. So this is the subarray that we have got. This maximum subarray that we have got. What does it says? It gives the information that if I was to end over here, the maximum subarray sum I would get is 2. If I was to end over here, the maximum subarray sum I would get is -3. If I was to end over here, the maximum subarray I would get is 4. Similarly, 3, 1, 2 and 7. So what can I do? Finally, I can take out the maximum value, which is 7. So 7 is going to be our answer. Why? Because 7 is the maximum sub that I will get if I consider this array. So 7 would be the answer. So this is Kadane's algorithm. What we are doing is we are dividing a problem into sub problems. So it's a dynamic programming approach, and rather than using those for loops, what we are doing is we are using the previous value for the next computation. We are using the previous knowledge, the stored value, for the next computation. So this is the essence of dynamic programming, right? So this is the Kadane's algorithm that he came about while he was listening to attending the seminar, and he came about it into a minute. And this is a linear time complexity algorithm. It's a beautiful algorithm. So yeah, let's try to code it up. Okay, so let's say we are given an array, and what we are going to do, we are going to have a max sum subarray, and this sub array will initially be let it be empty with none and n element. And now what I can have, I can also have the current maximum and let it be initialized to infinity, negative infinity. And for, let's iterate now for I in range n. Now let's iterate. If I see that the current element that I am at is greater than the current element plus my previous element, then in that case what I see, that I'll start afresh. So my current element, I'll put it as a of I, I'll start afresh. But otherwise, if it's not the case, if I see that the current element, if I extend the array, that's better option, then what I am going to do, I am simply going to add the current element to my previous sum. Okay, and at the end, the maximum sub, I am going to note this value, that maximum sub at ith position, until this position, the maximum sub array that I can get is going to be the value current. Okay, and at the end, what I can do, I can return the maximum of this subarray. So this is what we discussed, right? And let's try to run this, testing it. So yes, the answer is correct. Thanks a lot for watching this. I hope you enjoyed it.